Section 3.9 Antiderivatives. Definition: a function big F is called an antiderivative of small f on the interval I if big F prime of x equal to small f prime of x for all x in I. So let's look at the example. Given the big F function 1 over 3 x cubed, and if we take the derivative, then we will get f prime of x equal to x squared. We call this function is f small x. So then we say that the function big F of x is the antiderivative of the function small f of x. However, we not only have one answer for this. What if we have the big F of x is 1/3 x cubed plus 1, or in general we have 1/3 x cubed plus some number c. Then you take the derivative of the big F of x, the function f of x prime, which is the little f of x, is still x squared. So we said that in general, we said that the f of x equal 1/3 x cubed plus c is the most general antiderivative of the function small f of x. We have the theorem below. If the function big F is an antiderivative of f on the interval I, then the most general antiderivative of function small f on I is big F of x plus c, for c is any arbitrary constant. Example number 1, we want to find the most general antiderivative for each of the following function. So for part A, you know that the derivative, we look at the derivative table, and we know that if we take the derivative of cosine of x, negative cosine of x, we will get sine of x. So the most general antiderivative for the function sine of x should be negative cosine of x plus c. Problem B, if we take the derivative of x to the n plus 1 over n plus 1, then showing the work, we will get n plus 1 moving down, and then in the bottom you still have n plus 1. The x exponent will be n plus 1 minus 1 is will be n, and we will cancel the n plus 1. We will get x to the n. So the most general antiderivative of the function x to the n should be x to the n plus 1 over n plus 1, and then plus the constant, because if you take the derivative of this, the constant will become 0.